All right, we're looking at the answers to the four questions we worked on today in Canvas. Number one, we have f of x equals 2x cubed minus 9x squared plus 12x plus 4. So we start out by taking the derivative. Derivative of 2x cubed is 6x squared. Derivative of 9x squared is 18x. Derivative of 12x is 12. Derivative of 4 is 0. Set that equal to 0. Factor out a 6, which leaves me with x squared minus 3x plus 2. Factor that into x minus 2, x minus 1. So that gives me x values of 1 and 2. I do not have to worry about this 6 because 6 does not have a variable. All right, then we plug some numbers in. So over here, I'm going to plug in 0. So that's going to be positive. That's going to be negative. That's going to be negative. So positive, negative, negative gives me a positive. Plug in 1.5, positive, negative, positive. So positive, negative, positive is a negative. And plug in 3, positive, 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 which produces a positive. So at 1, we're changing from positive to negative. So that means we have a relative max at x equals 1 because f prime changes from positive to negative. At 2, we're changing from negative to positive. So that means we have a relative min at x equals 2 because f prime changes from negative to positive. In this section right here, in this section right here, our derivative is positive. So that means f is increasing. So f is increasing on those two intervals because f prime is positive. And in the middle, my derivative is negative. So that means f is decreasing on 1 to 2 because f prime is negative. Then we move on to the second derivative, which is what's going on over here. Derivative of 6x squared is 12x. Derivative of negative 18x is negative 18. Set that equal to 0 and solve it. Add 18, divide by 12. That reduces to 3 halves. So I put 3 halves on my sign line. On the left side is 0. Plug 0 into that. That's going to be 0 minus 18 produces a negative. Plug 2 in. 2 times 12 is 24. 24 minus 18 is a positive. So because my second derivative is negative, that means the function is concave down on that interval because, as we said, the second derivative is negative. F double prime is negative. F is concave up on the other half because F double prime is positive. And F has a POI at x equals 3 halves because F double prime changes sign. All right, question number 2. Our function is f of x equals 9 minus x squared to the 1/3 power. So we take the derivative, which requires a chain rule. So bring the exponent down. Inside stays the same. Subtract 1 gives me a new exponent of negative 2/3. Derivative of the inside gives me negative 2x. So clean that up. Gives me negative 2x on the top. And then 3 times 9 minus x squared to the positive 2/3 on the bottom. Set that equal to 0 and set each piece. So I'm going to set the top equal to 0 and I'm going to set the bottom equal to 0. So negative 2x equals 0 just produces x equals 0. On the other one, I can divide by 3. It gets rid of that. Then I can get rid of the 2/3. So I'm just left with 9 minus x squared. I solve that. I get plus and minus 3. So that means I need negative 3, 0, and 3 on my sign line. Now remember, since 3 and negative 3 came from the denominator of the derivative, I need to make sure it doesn't cause any problems back when I plug it in, and it doesn't. If I plug 3 in, it's going to give me 9 minus 9, which is 0, and 0 to the 1/3 power is 0. If I plug in negative 3, it's also 9 minus 9, which is 0, and 0 to the 1/3 power is 0. So no issues there. So that means all three of these are critical points. So now we plug in. I'm going to do negative 4. So negative 4 on the top is going to make it positive. On the bottom, because of this 2 right here, regardless of what goes on in here, my bottom is always going to be positive because I'm going to end up squaring it. So in this case, I've got a positive over a positive, and that's why that section is positive. My next section, negative 2, positive on the top. Again, the bottom is always positive. Positive over a positive produces a positive. Okay. Next section, let's plug in 1. Gives me a negative on the top, positive on the bottom. So that produces a negative. Then we plug in 4, negative on the top, positive on the bottom. That produces a negative. Okay, so there's only one place where my derivative changes signs, which is at 0. And we have a relative max at x equals 0 because f prime changes from positive to negative. Okay, f is increasing between negative infinity and 0 because these two sections, because f prime is positive. And f is decreasing from 0 to infinity because f prime is negative. So 0 to infinity, f prime is negative. Now, because -3 and 3 were critical points, but they were not relative extrema, remember that means that these two spots are going to be points of inflection. All right, so that's number 2. All right, next problem. F of x equals x plus cosine of x. We're only looking at the interval from 0 to 2 pi. Take the derivative. Derivative of x is 1. Derivative of cosine is negative sine. Set it equal to 0 and solve. So I add the sine over. So I have sine of x equals 1. So I'm asking myself, when does sine equal 1? And sine equals 1 at pi over 2. So my interval is 0 to 2 pi. So the start of my sine line is 0. The end of my sine line is 2 pi. And then I have pi over 2 here. So I need to plug in a value in between 0 and 2, in between 0 and pi over 2, which is anything in quadrant 1. So if I plug that in, this value is always going to be smaller than 1 because sine and cosine can only go between 1 and -1. So I'm going to have 1 minus a number that's smaller than 1. So that's positive. And same thing over here. This is going to be 1 minus a number smaller than 1. So that's also going to be positive. So we did not change sign, so that means there are no relative extrema, but we can say f is increasing on the interval from 0 to 2 pi because f prime is positive. We go to the second derivative. Okay, and as you notice, pi over 2 is a critical point, but not an extrema, so that means it's probably going to be a point of inflection. So let's see if that happens. Derivative of 1 is 0. Derivative of negative sine is negative cosine. So I divide by -1. I ask myself, when does cosine equal 0? And that happens at pi over 2 and 3 pi over 2. So 0 and 2 pi start my sine line. Pi over 2 and 3 pi over 2 are on there as well. Okay, so over here, I'm going to plug something in. This is 0 to pi over 2 is quadrant 1. We know that everything in quadrant 1 is positive. So when I plug that into cosine, I'm going to get a positive value, but I have to multiply it times the negative. So that gives me a negative. And this section right here, so that's between pi over 2 and 3 pi over 2, which is the left side of the graph. So we know cosine on the left side of the graph is negative. So that's going to be a negative times a negative, which produces a positive. Then in this section, we're back over on the right side. So we know cosine is going to be positive times a negative produces a negative. So f is concave down on this first interval and the last interval because f double prime is negative. F is concave up in the middle interval because f double prime is positive. And we can say that f has points of inflection at pi over 2 and 3 pi over 2 because f double prime changes sign. And question number 4 is our table problem. So b of x equals f of x squared. So the first thing we need to do is take the derivative. So derivative of b of x is b prime of x. And this requires chain rule. So derivative of the outside is f prime. Inside stays the same. Derivative of the inside gives me 2x. Okay, then I'm going to plug in my x value of 2, which is what they gave me. So I plug 2 in there. I plug 2 in there. 2 squared ends up giving me 4. And 2 times 2 gives me 4. So I need f prime of 4. The chart says is 0. And then 0 times 4 gives me 0. So because the derivative is 0, then that means x equals 2 is a critical point of b. So now we want to tell whether or not it's a max, min, or neither. So I need the second derivative. So second derivative, so there's the first derivative. Second derivative requires the product rule. So I got first times the derivative of the second plus the second times the derivative of the first. So that would be derivative of the outside. So derivative of f prime gives me f double prime. Inside stays the same. Derivative of the inside is 2x. Okay, so then I move the 2 to the front. I put the 2x and the 2x together and got 4x squared. Then we plug in our x value again. Plug in 2 there, plug in 2 there, plug in 2 there. So 2 squared gives me 4. 2 squared is 4 times 4 is 16, and 2 squared is 4, so that's why there's a 4 there. F prime of 4 is 0. F double prime of 4 is -3. So this is 0, and 16 times -3 gives me -48. So now we know B has a relative max at x equals 2 because B double prime at 2 is negative. And if my second derivative is negative, that means I'm concave down. So a critical point on a concave down section is going to be a max. So that is question 4.